Hello everyone. In this video, we are going to see about multiplexer. So you are going to see what is a multiplexer, and we are going to see how a decoder circuit can be converted to a multiplexer, and what is the difference between decoder circuit and the multiplexer circuit. So first we are going to see what is a multiplexer. A multiplexer is a circuit with many inputs but only one output. So you may have inputs, okay, it may have 2, it may be 3, it may be 4, it may be many, but finally you will get only one output. The selection of a particular input line is controlled by a set of selection lines. So here the only difference is you will have a separate selection lines, okay. So you are going to see about it. Normally there are 2 to the power n input lines whose bit combination determine which input is selected. So here you will be having 2 to the power 2 means 4 input lines, 2 to the power 3 means 8 input lines. Okay, it goes on like that. Okay, and its bit combination 0 0 means it will have one input line, separate input line. It's same like your decoder. Okay, so you will be having only difference is you will have some selection lines here. You will see what it is. Okay, and the multiplexer is abbreviated as MUX. So they normally in short form. Okay, they'll nicknamed as MUX. Now we are going to see how a decoder is being converted. Okay, how to use a decoder and convert it into a multiplexer. You already seen a decoder in previous video where you have it is a 2 cross 4 decoder. Okay, in the left side you can see A and B as the input, and you have uncomplemented A and complemented A. That is A and A dash, B and B dash, and you'll have 2 input which is connecting. So you already seen that in previous video. Here you got one extra input lines. Okay, for each AND gates you can see it is not only 2, it is 3 lines will be connected. Okay, so that is the difference between normal decoder and a multiplexer. Okay, so after drawing the extra input lines, you can see that and all the output for AND gate, whatever you got, it is connected to an OR gate. Okay, so that will that becomes a single output. So you may have many input, okay, for which it is connected to AND gate, and then all the AND gate output will be connected to an input for the input for OR gate. And finally OR gate produces only one output. So you may have many input, but for multiplexer finally you will get only one output. So this is how you are going to get a decoder, okay, which will be connected to a multiplexer. Now for multiplexer some differences are there. You can see instead of A and B, okay, rename that A and B as selector lines. You can call it as S0 and S1. Okay, you call it as selector lines, and rename that the selection line, separate input lines you are given. Okay, so for each you can name it as input I0, I1, I2 and I3. That will be the input, separate input lines which has been connected. Okay, and when you connect the output lines, okay, you can see that after AND gate you got the output as F0, F1, F2 and F3. That will be the output lines which is connected to an OR gate. The OR gate will be producing only one output. So this is what the multiplexer look like. Okay, now the function table and block diagram of 4 to 1 line multiplexer can be written. You can see selection lines S0 and S1. Okay, where you have the combination 0 0 0 1 1 0 and 1 1. So this will be the truth table which has the output I0, I1, I2 and I3. Okay, so this is a normal truth table which has the binary codes. Okay, the combination of binary codes. Same thing can be drawn and as a block diagram of the multiplexer like this. So you can see 4 input lines where you have I0, I1, I2 and I3. Okay, which produces only one output. Okay, this is just a resemblance, that is, it is just a block diagram. Okay, where you have 2 selection lines. You can see S1 and S0. Okay, that will be the selection, that is extra here. Okay, and it will have an output, single output for 4 cross 1 MUX. Okay, hope you understood this video. We'll meet you in the next video. Till then, thank you.